We've all seen the pictures. We've all heard the story, right? It's etched into our collective consciousness. Thousands of workers, years of backbreaking, brute labor, and a few simple ramps. That's the classic tale of how the Great Pyramid of Giza was built. But here's the thing. The numbers don't lie. And the newest, most incredible scans from deep inside this ancient marvel are forcing engineers, scientists, and even seasoned archaeologists to ask a question most textbooks still stubbornly refuse to print. What if the greatest architectural feat on Earth, a structure that has defied time for millennia, was actually pulled off with a technology we've simply forgotten, a cleverness we've underestimated? What if the story we've been told is just incomplete? For a century, the script remained largely unchanged, a narrative woven from ramps, sledges, and immense human sweat. It felt neat, tidy, and safely within our understanding of ancient capabilities. Then, things got interesting. A groundbreaking 2023 muon sweep mapped a 9-meter vaulted corridor no one, not a single soul, knew existed, tucked away deep within the pyramid's north face. Add that to the monumental 2017 discovery of the Big Void, a massive, unexplained chamber hovering above the Grand Gallery. And let's not forget the mind-boggling precision of the pyramid's base alignment. An error so tiny it is smaller than the thickness of a playing card across its vast expanse. Suddenly, that comfortable, textbook story of simple ramps and brute force starts looking less like a definitive history and more like a very rough, incomplete draft. The hidden science of the pyramids isn't hidden because it's some grand secret, guarded by ancient cults or extraterrestrials. It's hidden because it never quite fit the convenient, simple narrative we've clung to for so long. The official story and the math that breaks it now, let's be fair. Let us give credit where it has due. The mainstream ramp theory isn't completely crazy on the surface. Archaeologists have indeed found compelling evidence like post holes, sled ruts, and even a fascinating 4,500-year-old papyrus diary detailing limestone shipments to Giza. These are real clues, pointing to real methods. But the problem, the truly insurmountable hurdle, is scale. Think about it. We're talking about hoisting 2.3 million colossal blocks, some of them weighing a staggering 15 tons each, roughly the weight of 2 adult elephants, to a height that would easily swallow a modern 40-story building. Consider the ramp options. The straight-on ramp. To reach the top of the pyramid at a workable incline for dragging heavy stones, a straight-on ramp would need to be absolutely enormous, requiring more material than the pyramid itself. Where did all that ramp material go? Why is there no trace of it on the Giza Plateau? It just vanishes? The spiral outside ramp. Imagine dragging a 60-ton granite beam. That's a small tank. Folks around the tight 90-degree corner every 12 meters, all the way up a spiral ramp on the pyramid's exterior. The logistics are a nightmare, the friction immense, and the sheer force required would be astronomical. The spiral inside ramp. This one's a bit smarter, a more elegant solution often proposed. But here's the rub. No internal ramp has ever been found, despite extensive scanning and exploration. And even if one existed, the tight switchbacks and sharp turns would place unimaginable shear stress on the cedar sledges and ropes, likely snapping them repeatedly under the immense weight. Then there's the math for the human haul model. Conventional estimates suggest a workforce of around 20,000 to 30,000 skilled laborers could finish the job in 20 years. Sounds plausible, right? Until you break it down. That means each crew would have had to place one block every 2.5 minutes, non-stop, daylight and dark for 2 decades, without a single slip-up or break. That's conveyor belt territory, folks. A level of relentless efficiency that feels utterly impossible for guys with ropes, chanting, and basic tools. It's a logistical fantasy, not an engineering reality. The numbers just don't add up to the simple story we've been told. Enter the new evidence. So, If the old story has holes, what's the new evidence telling us? Let's lay it out. Exhibit A. Precision. Forget pretty good for the Bronze Age. The pyramid's base is leveled to within an astonishing 21 millimeters across its entire 230-meter length. That's a tolerance level so tight it's actually illegal in modern airport runway specifications. Think about that. We're talking about a structure built over 4,500 years ago, achieving a level of precision that challenges our best contemporary construction standards. How did they achieve that without laser levels or advanced surveying equipment? Exhibit B. Internal chambers. This is where the non-invasive magic of muon tomography comes in. Muons are subatomic particles that constantly rain down on Earth, and like X-rays, they can pass through dense objects. By tracking their paths, scientists can create 3D maps of internal structures without ever touching the pyramid. And what they keep finding is empty space where none should be. First, the monumental 30-meter-long Big Void hovering eerily over the Grand Gallery, a space big enough to hold a Boeing 737. Now, a newly mapped vaulted corridor tucked behind the north face. These aren't just small cracks. They're significant, deliberate architectural features. And here's the kicker. No burial goods, no soot from torches, no telltale chisel marks. Just raw, untouched limestone walls. What were they for? Exhibit C. The granite beams. Look at the King's Chamber. The massive granite beams there show undeniable signs of pressure spalling. That is when stone flakes off due to intense rapid pressure, not gradual wear. This kind of damage is consistent with rapid, controlled loading, the kind you'd see from a hydraulic jack, not the slow, grinding drag of sledges and ropes. Put these three pieces of evidence together: unbelievable precision, hidden voids, and specific types of stone damage, and a signature phrase keeps popping up among the engineers studying this. The ancients weren't fighting gravity, they were managing it. They weren't just brute forcing their way through. They were using intelligence to outsmart the forces of nature. Hydraulic engineering, not fantasy. This brings us to a theory that's gaining serious traction among a growing number of researchers. Hydraulic engineering. And no, we're not talking about some sci-fi fantasy. This is real, testable, ancient technology. Consider a crucial discovery in 2022. Excavations around the step pyramid of Djoser, predating Giza, revealed compelling evidence of a temporary lake held by a clay dam, specifically designed to fill the pyramid's surrounding dry moat. What does that mean? Fill the moat with water, float a massive stone on a barge, open a sluice gate, and you suddenly have a highly efficient water elevator. It's elegant in its simplicity. Now, let's translate that brilliant trick to Giza. Imagine a controlled spillway system built right up one face of the pyramid, creating a sophisticated step lock system, much like modern canals. Each colossal block could ride a sealed float or caisson, which would then rise effortlessly as water filled the chamber. Once it reached the next level, it would be locked into place, the water drained, and the process repeated for the next lift. No impossible sledges, no need for a 300-meter ramp, and those mysterious internal voids we're finding? They suddenly make perfect sense as water regulation shafts, conduits, or even buoyancy chambers, integral to the system. This isn't just armchair speculation. French fluid dynamics engineer Xavier Landreau actually built a 1/10 scale model of this system. The results were astounding. Two people, using nothing but controlled water flow, were able to raise a 250-kilogram block 3 meters in just 12 seconds. Now, multiply that leverage. Suddenly, lifting a 15-ton block becomes a manageable, efficient one-team job, not a Herculean effort by thousands. And here is another beautiful connection. This same hydraulic system that lifts stone also offers a compelling explanation for the peculiar copper tool wear patterns found in the quarries. Repeated wetting and drying, a natural consequence of working in a water-based construction environment, would have hardened the metal edges faster through a process called work hardening. This would give the illusion of massive, relentless labor and tool replacement when, in reality, the true trick was the ingenious application of hydraulics and incredibly precise scheduling. It completely changes our understanding of their work process. Lost tech or forgotten know-how. So, was this technology truly lost? Perhaps it's more accurate to call it a forgotten technology, rather than one that simply vanished. The principles of buoyancy and hydraulic leverage weren't unique to the Egyptians. Roman aqueduct engineers, for instance, famously used the exact same buoyancy principle to position incredibly heavy 50-ton columns. Centuries later, Venetian builders employed similar water-based techniques to float entire marble facades into place during high tide, leveraging the power of the natural environment. The crucial difference here is the sheer scale and the incredibly compressed time frame in which the Egyptians mastered and applied this knowledge. They compressed what might have been centuries of trial and error into a single monumental build window for Khufu's pyramid. Once the Great Pyramid was completed, once the pharaoh's eternal home was secured, the massive clay dam was likely dismantled. The Nile channel that fed the system eventually silted up, and a highly specialized know-how, much like a closely guarded trade secret, simply retired from active use. That's why we don't find colossal ramp ruins littering the Giza Plateau. And it's why Herodotus, writing 2 millennia later, heard only tantalizing rumors of machines made of short planks. A vague description that might actually hint at the floating casings or lock mechanisms used in a water-based system rather than simple levers or ramps. The knowledge wasn't necessarily eradicated. It just wasn't widely disseminated or continuously practiced, fading into the mists of time as the need for such colossal undertakings diminished. What Egyptologists say now, it's important to acknowledge that mainstream scholars, quite rightly, raise a couple of fair objections to the hydraulic theory. And these are valid points that need addressing. First, they argue there are no ancient texts that explicitly describe water locks or hydraulic systems being used for pyramid construction. This is a powerful point. However, the counter-argument is equally compelling. There are also no ancient texts that explicitly describe the use of massive external ramps for pyramid construction. Both sides, therefore, are largely inferring tools and methods from archaeological context, engineering feasibility, and indirect evidence. The absence of a text doesn't automatically negate a theory if other evidence points to it. Second, and perhaps more challenging, is the question, where did all that water go? If you're filling and draining massive chambers, you'd need an incredible amount of water, and then you'd have to manage its disposal or recirculation. This isn't a minor detail. But once again, modern simulations offer a fascinating potential answer. Calculations show that the porous 2.6 million cubic meters of the Giza Plateau, the very ground the pyramids stand on, could actually absorb the massive amounts of water required for a 4-week fill-drain cycle. This would necessitate a colossal catch basin, perhaps the size of 3 football pitches, to manage the influx and outflow. And guess what? Much of the area where such a basin would have been located now lies conveniently or inconveniently under modern suburbs and urban development, making archaeological investigation incredibly difficult. So, until archaeologists actively start looking for telltale signs like hydraulic plaster layers, the remnants of clay dams, or specific erosion patterns consistent with spillways and sluice gates, the jury truly stays out. But the silence from the ancient texts or the lack of immediately obvious water features isn't necessarily a denial of the theory. It's more like a mountain of fascinating homework waiting to be done. It's an invitation to look with fresh eyes. Lingering mysteries. Even if the hydraulic aid theory ultimately cracks the monumental problem of weight and lifting, it doesn't solve every puzzle. The sheer precision remains a breathtaking enigma. For example, the descending passage within the Great Pyramid points to true north with an astonishing error of just 0.05 degrees. That's tighter, significantly tighter, than the meridian line of the Paris Observatory, established in 1667 with advanced instruments. How did they achieve that level of geodetic accuracy? And then there are the astronomical alignments. The shafts leading from the Queen's Chamber, for instance, align with the constellations Orion and Sirius in 2450 BCE exactly, not a century earlier, not a century later. This implies an incredibly sophisticated understanding of celestial mechanics and a precise dating of the pyramid's construction. Did the builders reset their entire site alignment nightly to compensate for stellar drift? Or did they possess surveying gear and astronomical knowledge far beyond anything we've ever recovered or currently attribute to them? And those newly mapped voids? The 2017 Big Void, the 2023 Vaulted Corridor? They're sealed. Completely. There's no obvious entrance, no copper fittings, no ancient graffiti. Just raw, undisturbed limestone walls. Until a micro-robotic drill tip can safely slip inside and send back images. We're left to guess at the function of a corridor no human eye has seen, no human foot has trod for 4,500 years. Are they relieving chambers, part of the hydraulic system, or something else entirely? These aren't minor details. They are fundamental questions about the pyramid's true purpose and construction that continue to baffle us. If these numbers and mysteries are already bending your brain a little, stick around, because next, we're going to stack this new, compelling theory against every mainstream model, and watch where the flaws light up like seismic fault lines. Don't go anywhere. Hit that subscribe button and keep scrolling. This investigation is just getting airborne, and you won't want to miss what we uncover next. The comparative stress test. Let's put all the major theories under the microscope, shall we? Let's run a comparative stress test and see which one holds up best. The ramp model. We've touched on this, but let's be blunt. It needs 1.5 times the pyramid's own volume in extra fill material. Where is it? It leaves precisely zero archaeological footprint. That's not just a problem. It's a glaring, almost impossible absence of evidence. The crane model. Some suggest massive cranes. But the Egyptians only had iron in tiny, rare meteoric beads, not in structural quantities. A wooden crane, no matter how clever, simply snaps under the immense moment arm required to lift a 15-ton block to those heights. It's a structural impossibility with their available materials. The human haul model. This is the most widely accepted one, but its energy budget is a nightmare. To move those blocks at the required pace, each worker would need to burn an estimated 1,600 calories per block per hour. That translates to each laborer needing to consume over 6,000 calories daily, day in and day out, for decades. This is utterly impossible on the simple bread and beer diet that archaeological evidence suggests was available to the workers. They starve from exhaustion. Now, let's look at the hydraulic float model. It requires roughly 30 megaliters of water, which is a lot, but manageable with the Nile nearby. The energy is sourced from gravity and buoyancy, not impossible human effort or snapping wood. The workforce drops dramatically, potentially to around 4,000 skilled individuals, a number far more realistic for sustained, complex engineering. Crucially, the calorie demand for the smaller, more efficient workforce falls well within a nutritional range achievable with the ancient Egyptian diet. And here is the clincher. Carbon dating of mortar found between the pyramid stones constantly shows construction seasons clustered in the summer and fall. What's significant about that? It's precisely the peak Nile flood season. Coincidence? Possibly. But a predictable, abundant water supply for a hydraulic system? Absolutely. When you weigh the burden of impossibility for each theory, the ledger tilts dramatically, decisively, toward water power. It's the theory that demands the fewest fantastical assumptions and aligns best with the available evidence. Why the controversy sells? It is no secret why some speculative documentaries immediately chant aliens or invoke lost super civilizations whenever the pyramids are mentioned. Its ratings catnip, pure and simple. It's sensational, it's easy, and it provides a simple, albeit fictional, answer to complex questions. Conversely, many respectful mainstream channels often swing back to the pure muscle and ramp narrative, perhaps to stay safe, to avoid accusations of fringe thinking, or simply because it's the long-accepted dogma. The real tragedy is that the gap in the middle of the space for real engineering, for testable hypotheses, for actual, rigorous math and scientific inquiry, often gets crowded out, ignored, or simply deemed too boring. Yet, that's precisely where the real, profound mystery lives. The pyramids aren't confounding because they're impossible, nor because they're the work of beings from another world. They're confounding because they stand as irrefutable proof that ancient people were far smarter, far more ingenious, and possessed a level of sophisticated engineering knowledge that our modern stereotypes simply haven't allowed for. Every time a new corridor lights up under a muon scan, every time a new piece of data emerges, we're reminded that humility, a willingness to reconsider, and a dedication to scientific inquiry, not fantasy, is always the correct scientific response. It's a challenge to our own assumptions. The takeaway: so, what exactly can't Egypt, or rather, our conventional understanding of ancient Egypt, explain? It's not just one thing, it's several, all pointing to a deeper, more intricate reality. How did their surveyors hit sub-millimeter tolerance on a 230-meter polygon without modern tools? Why do internal voids, like the Big Void, seem to mirror the precise load angles of the Grand Gallery if they were only simple, relieving chambers or structural anomalies? And if water engineering played such a pivotal role, where are the unmistakable sluice scars, the remnants of water channels, or the hydraulic plaster layers? These questions remain wide open, not because the answers are unreachable, but arguably because the last century of archaeological inquiry, so focused on finding evidence for ramps and brute force methods, may have inadvertently trained our eyes to miss everything else. We looked for what we expected to find. Thankfully, new, non-invasive technologies, muon tomography, LiDAR, advanced fluid simulations, and precise carbon dating are finally giving us the crucial second opinion. They're allowing us to see the pyramid not just as a static monument, but as a dynamic, complex engineering marvel, inviting us to ask better questions and look for different answers. Conclusion: the hidden science of the pyramids isn't some whispered secret from aliens, nor is it a forgotten cheat code from the mythical city of Atlantis. It's far more grounded and far more inspiring. It's a working, elegant combination of buoyancy hydraulics, advanced astronomy, and meticulous project management, all executed by people every bit as clever, every bit as innovative as today's leading engineers. They were just armed with a different, perhaps more organic set of tools and knowledge. The math, with this new perspective, finally starts to add up, making the impossible seem plausible. But the complete blueprint, the full story, is still half erased, waiting to be deciphered. Each fresh scan, each new discovery, peels back another intricate layer, revealing that the greatest monument on Earth is also, perhaps, the oldest and most complex engineering textbook, one we're still diligently learning how to read. Until the next discovery, keep asking the numbers to testify. They've already confessed that the story we've been told is only chapter 1, and the rest? It's waiting to be written. Ready to keep digging into history's hardest puzzle? Hit that subscribe Sensei mystery. Drop your take in the comments. Are you Team Ramp, Team Water, or something even wilder? And join the ongoing hunt for the truth behind these incredible ancient wonders.